Forget everything you thought you knew about electronics design. AI is about to blow it wide open. The future of wearables isn't just smaller, it's virtually invisible, thanks to a radical shift in how flexible PCBs are engineered. Get ready to see the cutting-edge intersection of artificial intelligence and Altium as we reveal how future devices will literally conform to your life. AI is revolutionizing electronics engineering, especially for wearable technology, by automating and optimizing various stages of the design process. Within Altium, AI capabilities are harnessed for component placement, trace routing, and design rule checking, leading to increased efficiency and reduced errors. AI algorithms can analyze billions of configurations to identify optimal designs for performance, power consumption, and area. This is particularly valuable in complex Flex PCB designs where space is limited and conformity to irregular shapes is required. AI facilitates the creation of ultra-thin flexible PCBs with higher component density through techniques like embedded passives and 3D stacking. These advanced methods reduce board thickness while maintaining full functionality, crucial for compact wearable devices. AI tools automate component placement and conductive path tracing, enabling designers to experiment with different configurations rapidly. AI-driven trace routing minimizes interference, while automated component placement optimizes complex curves on flexible PCBs. This significantly reduces the need for manual intervention, though some refinement may still be necessary. AI anticipates design flaws through simulations, optimizing performance, power efficiency, and manufacturability. This leads to faster development and better integration between hardware and software, essential for IoT devices and wearable electronics. Altium is integrating AI features to streamline the design of Flex PCBs, offering a unified design environment. Here, rigid and flexible sections are designed in the same workspace, enhancing collaboration and efficiency. Altium software has built-in machine learning to increase productivity with design flows and countless other features. AI-powered design assistants automate schematic capture and component selection, allowing engineers to focus on creative and critical thinking. Flexible PCBs are reshaping how we interact with devices, particularly in the wearable market, where they are a must-have feature. The demand for wearables is projected to reach over $180 billion by 2026, making flexible PCB mass production key. Emerging trends include advanced materials like graphene for even thinner and more conductive flex circuits. We also see the integration of flexible PCBs with stretchable electronics, allowing devices to conform even more closely. Despite advancements, AI is not yet capable of completely replacing human designers due to the complexity and nuanced decision-making required. However, AI-driven tools enhance efficiency, reduce development cycles, and improve system performance significantly. It's important to consider AI's limitations, such as the need for manual refinement and the potential for unexpected errors. Several AI-powered tools like Sealess Design Studio, Flux AI, CircuitMind, and KiCad MCP Server aid in PCB design. When designing flexible PCBs with Altium, engineers must consider the unique layer stack with flexible substrates and accommodate motion. Engineers should also pay attention to mechanical properties like bend radius and pattern rigid sections for component mounting. Altium offers features such as a specialized layer stack manager, flex and rigid routing capabilities, and flex modeling to aid in this process. AI is also transforming PCB design education, with partnerships between companies like Altium and Mouser playing a pivotal role. Educational institutions are incorporating AI into their curriculum to ensure students are skilled in cross-disciplinary aspects of mechatronics. This prepares them to partner effectively with mechanical and firmware engineers, shaping the future of electronics design.